Just checking the audio whether it is being recorded. Okay, right. Actually, we have a quiz by July 13, right? So we can move forward to week 5 lectures, or we can do some problems based on week 4, since we have seen many problems till week 3. So it's your choice. You can type it in the chat box what you want. If I can move forward with week 4 and we can do problems on Wednesday or Friday, that would be fine. Otherwise, we can solve problems today from week 4.
In GA3 only one question I left out. That's 6 minutes. It's a reference one question. So
Week 3, right?
yeah, GA3 that question number
Can we
6.
discuss this at the end of this session?
Okay, as you wish.
Right. So, rest of the people or everybody, please type your preference in the chat box. We will go with most of the preferences. Or you want me to revisit week 3, week 4 lectures? You want me to solve some problems till week 4? Or I can move forward with week 5 contract. Yeah.
We want to solve the questions.
Week 3 and 4 questions? Okay, right. Good. Yeah.
And ma'am, I have doubts regarding week 3 GA.
Yeah.
Same question, 6, 7 and 8.
Right. We will keep that for the end of the session. Last 30 minutes we will discuss on that. We'll start solving some problem. If that will help you solve that problem, that would be fine. Otherwise, I will try to answer your questions. Okay. Let's go with the agenda. Okay, I'll solve some problems till week 4. I'll start with week 4. Then, if we have time, we'll revisit some problems from week 3. Let me share my screen. Good. We have last Friday we have solved some problems based on time response analysis and also steady state error. We'll try to solve more problems in that domain. Take some time. I'm not aware of this. Did you learn Routh-Hurwitz array? Routh-Hurwitz array? Not it, right?
I guess it's in week 3,
It's in week three.
but we have doubt. Means like we are not finished our hands over it.
Okay. Routh-Hurwitz is in week three. Did you people study that? Stability, two zeros. Stability have seen. Great. Okay. Let us solve some problems on time domain responses. I hope my screen is visible, right? First question on time domain response. A system has a damping ratio of 1.25, natural frequency 200 radians per second, and DC gain of 1. The question is the response of the system to a unit step input. They are asking, right? So from this, can you find the symbols? Damping ratio means it's zeta, we know, right? Natural frequency means it's omega n. What else it was given? DC gain they have given. And they are asking us to find the response of the system for unit step input. This is also a input side, sorry, question side, how to say, this is also an important input for us. It's a step input signal. So straight away you can think of 1 by s in terms of Laplace transform. So we have all these things. They are asking for the response of the system, that is C of s or Y of s, whatever way we use the notation. That is the output response of the system. But I can see the options here, but I don't want to give the options right now. Just we try to find it. It is in time domain. Okay. The options are in time domain response, that is in terms of y of t, not in y of s. So we have to use some tools that can be solved either using Laplace transform and inverse Laplace transform to find the answers in time domain. Otherwise, we can use formulas that are straight away in time domain. Both ways we can solve. We are going to take the simpler route, that is solving it in Laplace doing inverse Laplace transform to find out the time domain response. This is the first hint I'm going to give you. Then from the questions, try to write down the all the known facts. The omega n, that is 200. Then zeta damping ratio they have given, that is 1.25. What else they have given? DC gain k they have given, that is 1. So these are all the known information. Also we know the input, that is r of s, it is equal to 1 by s. Otherwise you can call it as unit step, because r of t, I will write it down. R of t, they have given it as u of t. It's unit step response, so I am going to take this. I have to find the u of t. This is the question. Right. First thing we can do is just since this is a time response based question, try to write the standard form that we know. Y of s divided by r of s is equal to omega n square divided by s square plus 2 zeta omega n s plus omega n square. This is the standard format we all know. Right. Here, when compared to this is here, zeta is here, yes, it's a complex term we know in Laplace transform. What else it was given? R of s they have given, y of s we have to find. Okay. Then one important thing that is here, which is not in the standard form. What it is? That is the DC gain term. So if the DC gain term has been given, we can redefine this in terms of k into omega n square. There is one additional DC gain term, that's it, plus 2 zeta omega ns plus omega n square. If the DC gain terms is not given, we are considering it to be a 1. Here also it is given, but it is 1, that's okay. We are going to rewrite it in terms of this. Right. Now, I'm going to substitute everything for this. What omega n square means, it will be 40,000, or I will write in terms of this itself. Okay. 200 square into 1 divided by s square plus 2, zeta is 1.25. With 1.25, you should know that this is a overdamp system, right? Greater than 1. And omega n is 200 s plus 200 square. Right, good. Now I'm going to write just simplified terms. S square plus 500s plus 40,000. Since we are in the learning stage, I am going one by one. Once you know how to solve by yourself, this will be easy for you. It won't take this much time. Okay. And I'm going to keep only y of s here, and going to take this r of s this side. What r of s we know is into 1 by s we know. Okay. Now I'm going to take the this in terms of y of s, I know this will be 40,000 by s whole by s square plus 500 s plus 40,000. This is y of s, but I need y of t, so I'm going to take the Laplace inverse of y of s, which will be Laplace inverse of this whole term here. When I take this, I have to take this in terms of partial fraction. When I take the factors out of it to make it simplicity, this 40,000 can be separated, and 500 it should come, right? I can 500. I can separate it as 400 and 100. Add both of this, I will get 500. If I multiply this, I will get 4,000. Oh, good. So there is another term that I am going to keep as it is, 40,000 by s. This will become s plus 100 and s plus 400. Right, good. Now I'm just going to take this down, just to consider what are all the poles and what is the type of the system. Just type is equal to number of poles at the origin. So here the type of the system is equal to 1. Just additional information not needed for this problem. Okay, right. Now I have to take the Laplace inverse for all these things. So this will become a by s plus b by s plus 100 plus c by s plus 400 equal to 40,000. Can anyone quickly solve this and find the ABC and tell me? I will also solve. Just solve by yourself and let me know. this will become minus 3b is equal to 4, b equal to minus 4 by 3. When I put s is equal to minus 400, try to solve along with me. This will become minus 400 c minus 300. Yes, did I make any mistake here? No, right? Greater into minus 300. Why am I doing this? Okay. It's equal to 40,000. Again, this will cancel. This will be cancelled. 3c is equal to 1, c equal to 1 by 3. Anybody found what is a?
A is 1.
A is 1, right. If you put 0, you will get a is equal to 1. So at last what you will get 1 by s, b minus 4 by 3 by s plus 100 plus c is 1 by 3 by s, what it is, s plus 400. Right. Now just take the inverse Laplace transform. You will get 1 by s, inverse of 1 by s is 1 minus 4 by 3 into e power minus 100t plus 1 by 3 into e power minus 400t. So this will be your y of t. That's it. This is the answer. The essence of solving this kind of problem in the sense, you will get the time domain response specifications for all the standard forms. Since there is no k or k is equal to 1, this problem is simple. If you have k equal to 2, you have to consider this standard format and you have to put 2 here and try to solve this problem in the same way as we did before. Right. So when you get this, try to see whether the option is in time domain or frequency domain. If the option is given in terms of frequency domain, you can stop the problem here itself, right? You don't need to find any inverse Laplace transform. You can stop the problem here itself and choose the best option. But it won't be straight away. So it will be in terms of y of t. So we are using inverse Laplace transform tools to find the output response in terms of time domain. That is the difference. So instead of this time domain response in terms of zeta, omega n, or k, you would have got something kind of TP, rise time, peak time, or settling time, combination of all these things, so that using this you can find the omega n and zeta. Then you have to apply this kind of problems can also be expected for 4 marks or 5 marks. That will also be an objective question, but you have to solve in the background to find the answer. This type of questions you can expect in the quiz 1. Right. So from this you should know all the formulas for this, what peak time formula, what it is, rise time formula. So based on the combination, you have to find the standard transfer function first, and then from standard transfer function try to use the inverse Laplace transform to come with the time domain output response. Right. So this type of question will you be able to solve? So for this you need to learn, these are all the key things you need to learn. Formulas for time domain responses, properties of Laplace, and inverse Laplace transform. You should be aware of all these things to solve this kind of problems. This could be some big question marks, big question problems. 4 marks, 5 marks, you could easily earn from this. Right? Any doubt in this? All right. If I want to repeat any step, or if you are stuck at any step, please ask me. I will try to clear those things. Good. We can move forward to some other problem, some other concept. Okay. I will ask you one question. Just try to answer it in the chat box. I will make four statements, give you four statements. Statement 1, statement 2, statement 3, and 4. I will write the option first, then I will ask the question. Okay. First, TD greater than TR greater than TS. Second is TD less than or equal to TR less than or equal to TS. TS greater than TR greater than TD. Relation between TD, TR, TS depends on the system parameter. So these are all the four options you have been given with. The question is, which of the following statement is true? You have to find the true statement for a step response of a underdamped system. Underdamped stable system, I would say. Given TD is the delay time, TS is settling time, TR is rise time. I will give you 2 minutes to think about it. If you want, just revisit that lecture content, what is rise time, settling time, and delay time, and try to answer this question from your point of view. What would be the best option according to you? So this, I'm asking for a system that is a underdamped stable system which produce bounded input, bounded output. If you give bounded input, it will give bounded output, not any unbounded behavior you would expect, but the system is underdamped. Okay. We are giving a step input. That's why it is asked for step response. For a step response of underdamped system, which of this options would be correct? Just think, take some time, think about it, and we can discuss on this. Look for the characteristics of the underdamped system. Look what is the zeta value of it, what could be the omega depends on what, and everything. And what is the relation between this zeta and rise time, zeta and settling time, zeta and delay time. Based on this, try to conclude. Where is that? Delay time, rise time. I have written it here so that you can easily compare it. Settling time, I'm taking just 2% tolerance for that. Right? Anybody can come up with any answer? You can unmute and let me know. Otherwise, I have to go and see the Gmeet box. Which could be the correct answer? Anyone volunteer? You can be wrong, no problem. Just try.
Option 3.
Option 3 you are choosing. Right. Why are you choosing option 3?
Ma'am, because in under dam systems, that's why
Okay.
TS could be denominated to the damping ratio. That's
Okay.
why TS should be good.
Uh, can you be more clear on this underdam system and how you are connecting this formula to the underdam system?
Ma'am, for under dam systems, the damping ratio is less than 1.
Yeah, it will be like this.
If denominator is less than 1, so
Okay. If
as
this is in the range of 0 less than or equal to zeta less than or equal to 1, then this will be higher. That's what you are telling.
yes, ma'am.
Right. Anybody else has any contradiction? When it comes here in the numerator, it will also be the same case. So this will pull it down. So TD will be last. TS will be first. That's what he is telling. Anybody has any contradiction or any question in this? No, it's correct. Actually, it's correct. So when you encounter this kind of question, just think about the nature of the system first. When it is an underdam system, you would expect some peak here, and then it will take some time to settle, but at last it will settle. That is the nature of the system. When you take a overdam case, if this is a set point, it will take a longer time to settle, but there might be some steady state error in overdam's case. It might reach this set point or it might not. In terms of critically dam, it's a perfect system and that has a lesser delay time, no overshoot kind of it. If it is an undam, it will be just an oscillatory signal, right? So you would not conclude anything or you would not get any useful thing for a common system. Right. If this is an under damped case, the zeta value will come fall into this category. So comparing to this rise time, delay time, using the formula, the intuition, just you don't need an exact value. You can just assume since 4 is there in the numerator, if this is under 0 to 1, then this will be the higher value, right? That's how this is. So the first close TS will be the higher. The rest of the things can follow as it is. So if you don't have any doubts in this question, we can move forward to the. This is a kind of intuition based questions where you can relate the concepts by your understanding. It is not any numerical solving type questions. It's just to grasp how much you understood the concepts. Okay. Now, shall we move to the next problem? I hope this is visible, right? The concept is in the right side. You can see the right side. Okay, I couldn't see what it is coming. Let me check once. Okay. Right. If I couldn't identify what you are saying, please unmute and speak to me. Okay. The third problem is still now I have been giving you some numerical input so that you can find some output. Now I am going to give some graphical based input. From that you are going to find the numerical based output. The first thing is I am going to give a output response of a system. Right. So this would be, let's take, how can I call this? The information I can give to you is this. Oh, okay, this is 1.25. And this is where it reaches peak is 1. My drawing is not very good. Just try to bear with me. Okay. Right? These are all the two inputs I can give you. From this, I'm going to ask you the unit step response of the system is shown above. Find the percentage peak overshoot and damping ratio. This is and. Okay. Can you come up with the idea? Not even the formula, just an idea how we can solve possibly. Can anyone come up with that? Just think about what are all the things you have learned so far. Try to connect the dots. We have given some numerical input in terms of graphical representation. From this, you are asked to find the percentage peak overshoot and the damping ratio. So try to think about the percentage peak overshoot formula. This is the formula you have. But the trick is, you should know which formula you have to pick. Another information I missed to give. It's 1. The final settling time is 1. Which should you pick? This one or this one? This is thumbs up, thumbs down. What did you choose? Thumbs up or down? I'm not seeing any answers right now. What formula we have to choose here? From this right hand side, you can see, right? So I have asked you to see which formula you have to choose based on the question. So what are all the information given and what should be the formula we can choose? First one or second one? For first one, give thumbs up. For second one, give thumbs down. Thumbs up. Okay.
One we should use.
Okay. Let them go with one. Alkesh and Sankeet.
Yes, ma'am.
What would you choose? First formula or second formula?
I think I'm at second.
Second. Okay. Right. Sankeet. Okay, I think he has some mic issues. We'll go with that. Okay, right. The information they have given here in this problem is TP. Peak time they have given, settling time they have given, where the final value, steady state value, it is reaching, there is no error. So the final value I can take it as, finally it is reaching to 1. So this is the two information it was given. If I choose the second formula, it has the information or it needs the information of zeta, but it is asked in the question. We don't know zeta yet, right? So it's better to go with the first formula. So in the first formula, if you see, this is TP, Y of TP, that is output response peak time. The second one is Y of infinity, that is a final settling time, where it is finally settling after a long time, after some time, where it is what is the final settling value. So these two information we have, so we can go with the first formula, that will be easy. So I'm going to write it in terms of Y of TP minus Y of infinity divided by Y of infinity into 100. So these two information we have, Y of TP is 1.25 minus 1 divided by 1 into 100. This would give you 0.25 into 100. That is 25%. So now you got the answer. Now, what is the second question? That is the zeta. To connect this bridge, we can take the second formula. Rest of the things we don't need. 100 into e power minus zeta pi divided by 1 minus zeta square percentage, right? Just equate this 25, put 0.25 here, or sorry, 25 here into 100, right? 25 here, e power minus zeta pi divided by root of 1 minus zeta square. If you solve this, you will get the zeta answer. Right. Can you solve and tell me the answer? Just equate this two things. Everybody getting answer? 0.4.
Yes, ma'am, doing.
Okay. Got the answer? We are getting 0.4. Solve the last question, right? I can move forward to the next question, I hope. If you didn't, let me know. Okay. Okay, good. Next, so till now we have seen some problems on time domain response, right? Now I want to see some problems on steady state errors. So we have seen how we can derive these formulas, and last week we have derived one table, no? If you are not there in that lecture, discussion, I will show you that. Wait, let me see. There it is. Mm, Here. So can you see the table that we have defined last week in the Friday session?
Ma'am,
Yeah.
ma'am, can you please share the notes from the Friday session?
Yeah, I have actually shared with the office people. I don't know why they are taking time.
Ma'am, actually, please do not share with office people because they have other work also. Just share it in our G space. That would be grateful for the student because we can directly access from the G space.
Yeah, right. But they have asked kind of link to me. They asked like it should be in some uniform order. With the, I have shared them with the recording link also. It should be directed to them. It seems.
Actually, it's like in our other subject also. It's like for DSP, Tony sir is taking us. So he, what he want to share us, he just share us in our G space. So it's not like office people come like a mediator between. So
Okay.
like, directly we can go for it. Therefore, we are for G space.
Okay. I will share it in the
Yeah,
GS.
that would be grateful. Means we do not ask to them, and you also do not go and to share them. So
Yeah, sure.
that was the thing.
Good. I will share it.
Yeah.
Okay, right. So you can. I hope you all can see the table. So this is one of the question that you can make use of those table. This is based on the week 4 lecture 4, I guess, last lecture. Okay. So here they have given information in terms of transfer function they have given. Sorry, transfer function we know, and ESS steady state error we know, and the input they have given is ramp input. So straight away we can write it as 1 by s square, and they have asked what is the k value in the transfer function. So we know the poles, steady state error, and here if you see, we should, for all the question that depends on this table, we should know two inputs. One is what are all the input, what is the nature of the input they are giving, this side, left hand side, the first column, and what are all the types of the system they are speaking about, that is type 1 0 or 1 or 2. Okay, from this input, can you say whether this is a type 1 or type 0 or type 2 system? The transfer function is g of s is equal to k by s into s plus 2 into s plus 3. Is it a type 1 or type 0?
Type 1.
Type 1 system, because we have one pole in the origin. So this is a type 1 system. We are interested in this table, in this column, and the input is unit ramp. This is unit step, this is unit ramp, parabolic. So we are going to see only this. So we want some output that is in terms of some finite number, right? Now how we can find the, what is the relation between this and the question? So if we want to find the ESS of a type 1 system with ramp input, we want to find ESS in terms of 1 by kV, where kV is equal to limit s tends to 0 s into g of s. Otherwise, you can also write in terms of 1 by limit s tends to 0 s into g of s, or limit s tends to 0 1 by s into g of s, right? So this is what you want. Left hand side it was given zero point 0.4, limit s tends to 0 1 by s into g of s is k by s into s plus 1 into s plus 2. Sorry, s plus 2 into s plus 3. Okay. Now 0.4 is equal to this, and this s will get cancelled. limit s tends to 0, 1 by k by s plus 2 into s plus 3. If I put 0 straight away here, 1 by k by 6 I will get. So this will be k by 6 is equal to zero point 0.4, and k is equal to, I'm right, right? I haven't made any mistake. 6 into zero point 0.4, what it would give.
2.4 newtons.
Ah, right. Can I fix? That's it. So you have to find the k value for this. This is one type of problem where you will where the transfer function half information will be given, left hand side will be given, and you will ask to find the k. The other way of this problem would be they will give the transfer function wholly, and you will be asked to find the ESS. Either way, you should have to know this table. That's it. So you should, if I have asked to find the type 2, if I give a square here simply, I'm just going to change this. So is it difficult to solve this problem from the table? Just look for the table, ramp input, type 2 system. Straight away you can choose the option that is 0. The steady state error, if I have asked, it would be 0. That's it. Otherwise, if I ask in terms of k, put ESS equal to 0, and you can just solve the problem as it is. K will also be 0, right? So you would expect some problems like this based on steady state error. The juggling will happen in inputs, type of the system. They can ask what if the step input is there, a parabolic input is there, or what if the system type is 0 or 2. Just it will cover only from this table. You can also be asked in terms of finding the position error constant, or velocity error constant, or acceleration error constant. These are all just kp, kb, ka. That's it. This terms, individual terms. Just try to relate the problem with this equation and inverse it to find the parameters, individual parameters, kv, ka, kp. That's it. Just try to solve some problems over there. So I can also redefine this problem. The next question is here I have solved three problems. So four, not blue, fifth question. So I'm asking in question number 4, what if k equal to 100? Some value I have given, and I'm asking you to find for a type 1 system. Same type 1 system. What is the acceleration constant? That is K. So the above system is type 1 system. So I'm going to rewrite the transfer function with the given information, s into s plus 2 into s plus 3. So what will be the Ka for this? Can you tell me? Acceleration constant. What is the acceleration constant? Are you feeling stuck here? Is it difficult to relate what is acceleration constant and ESS? Do you need help in this?
I guess a little bit.
Yeah,
Yes,
right,
ma'am.
right. Every time the acceleration constant, or the, for example, I will start with position constant. So
Okay.
position constant will be related in terms of 1 plus kp. Velocity constant will be related to ESS, will be in terms of 1 by kv. Acceleration constant will be related to steady state error by 1 by Ka. Okay, these are all the three relation. If the answer is expected to be finite, for example, for type 2, type 0 system, if I give step input, it will be finite. Then in terms of position constant, this is the relation. So if it is finite, this will be the relation. Okay, otherwise it will be either be 0 or infinity based on the input and the type of the system. For example, if a type 1 system, if the input is step, then this will be 0. Position constants will be 0. For a type 2 system, if the input is step, position constant will be 0. For a type C, the this position, velocity and acceleration is directly related to the input. Whenever the input is step, the output will be related to position constant. Whenever the input is ramp, the output will be related to velocity constant. Because whenever I will complete this parabola, this will be acceleration. How this is related in terms of, if you integrate step, you would get ramp. If you integrate ramp, you would get parabola. Meanwhile, if there is any position, if you integrate the position, you would get velocity, right? It's a direct physical relation. If you integrate velocity, you would get acceleration. So if there is a car, let's take, if there is a car and it is traveling in terms of, for example, this is the first position and this is the second position of the car, same car. Okay, now if I want to find the velocity, how will you know from this? I have only t, I know at what time it reaches there.
x2 minus x1 upon 2.
Yeah, right. It's nearly, it's a integration. We are integrating over t, over the period of time, right? Whatever the position information we have,
Yeah, yeah.
integrating over that. That's it. So this is the relation between them. So whenever you are asked to find position constant, the input must be step input. So this is the relation between these two. For example, in this question, the input is ramp. So you are asked to find the acceleration. But generally, if the input is ramp, you would be relating it to the velocity, right? But velocity will be the finite value. So when the input is ramp, the velocity will be the finite value for type 1 system. But for the same type 1 system, if the input is ramp, the output will be, steady state error will be infinity. So if the steady state error is connected to the acceleration constant by 1 by 0, then the acceleration constant should be 1 by 0. Then only you will get steady state error as infinity. That's why you are getting K equal to 0 here.
Okay. That means our acceleration constant is 0.
0. Your steady state error will be infinity. That's why your acceleration constant should be 0, because this is related in terms of inverse. Your ESS and the Ka is inversely proportional. So the question here is, what is acceleration constant with giving the ramp input for type 1 system. So your answer should be 0, infinite, sorry, 0, 0. Right, I will move forward to the next point. Okay, back to another intuitive based question, for instead of numerical question. For a second order system, if I give the peak time is 2 times the rise time, that is Tp is equal to 2 into Tr, then the system would be, this is the question. First option is underdamped, undamped, over, or critical. Just relate the formulas between Peak time and rise time, conclude the answer. If the peak time is twice as of its rise time, what would be the nature of the system? TP is equal to 2 into TR, where TP is pi by omega D, TR is 2 into pi minus phi by omega D. Omega D and omega D will get cancelled. So it will be 2 pi minus 2 pi. Then this will give you 2 pi is equal to pi, pi equal to pi by 2. Zeta can be related to cos phi, or tan inverse of pi zeta by 1 minus root of 1 minus zeta square. If these two are related, then what would be the zeta value or the phi value first? If this should be
So
equal,
value will be cos pi by 2. That value equals to 0. Zeta equals to 0.
zeta is equal to 0. How?
Cos pi by 2 na. Theta equals to pi by 2. Zeta equals to cos theta.
Good. This should be pi by 2.
Yeah, zeta equals to 0.
This should be, if this pi should be equal to 2 pi, your, no, it should not be pi by 2. Right. If I want to equate, if I want to make sure these both are equal, or sorry, 2 times of it, this term should go to 0, right? Then only pi is equal to 2 pi, TP equal to 2 TR. Then phi should be equal to 0, right?
Okay. So when zeta equals to 1.
Yeah, right. Sorry, I'm confusing you. You are right only. If the relation they have given, we should not see look for that relation, right? That is the input. You are right. You're right. If we want to
Actually,
from
I'll
this
tell you
relation,
everything.
yeah, from this relation, that is correct. Cos pi by 2 this should be, then the zetas would be 0. That's correct.
Yeah. So
Yeah.
what we are comparing that TR and TP?
This is the input. It should not be equalized, as I said before. This is the input. Based on this, we are going to derive it. This way, the way you derived is correct. So, based on this, if the zeta is 0, what could be this option? That's it. That is the question.
Zeta equals to, okay, if zeta equals to 0, then these are the options 1, 2,
Yeah,
3.
yeah. The system would be underdamped or undamped or overdamped or critical.
If zeta is less than 0, oh sorry, if zeta is less than 1 but positive, that means underdamped.
Uh-huh.
If zeta is greater than 1, that means overdamped.
Greater than 1, then it is overdamped. Yeah, right.
And for undamped zeta equals to 0. So answer would be undamped.
Yeah, right. Good.
And for critically damped, what should be the condition?
Zeta should be equal to 1.
Zeta should equals, okay, yeah. Critical damped comes in between.
That is a perfect kind of scenario where you would get
Ah,
no overdamped.
okay, in the first question, second question, in what we discussed, no? That,
Yeah, similar to that. Yes. This is not a numerical
actually,
base, but intuition aspects.
actually, honestly, I said that I haven't watched the week lectures with that week 4.
Okay, right.
Now I got.
Just revisit that and you will get some clear input.
Yeah, yeah, yeah. No, got it.
Okay, right. I think that is the problems from my side. But you people have asked some week 3 graded assignment questions, right? We
Yes,
can
ma'am.
discuss that. What
Week 4 is
question number you
seven.
said?
6, 7, and 8.
6, 7, and 8. Okay. Week 3. Is the deadline over?
Yes,
Yes,
ma'am.
ma'am.
Yesterday only.
Okay. Okay, right. So I will open that. Give me a minute.
And ma'am, please just share this in directly in your G space. Don't
Okay,
send
okay.
it to.
Right, right. I will also just intimate them that I'm sharing the content in the G space and I will
They
upload it.
have created the G space for that only.
Yeah, yeah.
Actually, they have created for the G space for us only. That directly we ask to you and just directly you share. Okay, for you, just say them, but it would be good. Otherwise, you share them, they will wait and then they will share us. So till that quiz will come and
Yeah, yeah, and I understood that, but I have not instructed like that. There is some miscommunication in that, I guess. I will share, no
okay,
problem.
okay, okay.
Okay, I have opened that. Wait, six questions. Six. It's a common data question, no? 6 to 8,
Yeah.
right?
Yes,
Ah,
ma'am.
see,
Okay,
6 minutes is a reference type. Yeah.
okay, okay. So summation here, u1. This will be plus, and this will be minus. Plus s minus 1 by s plus 2. This will be y. It's taking that. S minus 1. Okay. Oh, there is a summation here also. Helping. This, which is minus, which is plus here. This must be minus. This is plus, that is. Okay, right. First, this is the transfer function they have given. The first question is compute the transfer function from u1 to y. The location of the poles they have asked. Okay, first we have to find the transfer function. Then from the transfer function, we should say what are all the poles are. Okay. Uh, consider this first. Consider this as a SISO system. Single input, single output system. First question is the input is u1. Consider the input should be u1 and the output is y. That's how they have asked. So the transfer function would be, first of all, we know that whatever is there in the forward path that we called as g of s, whatever is in the feedback that we call it as h of s. This is a standard method we used to follow, right? I'm going to do the same thing to avoid the confusion. So when u1 to y you are considering, whatever is there in the above, that this term, this will be g of s and this will be h of s. So the transfer function would look like this: s minus 1 by, what is that, s plus 2 divided by 1 plus s minus 1 by s plus 2 g of s into h of s, whatever is there in the feedback, 1 minus s minus 2. Okay, this is your transfer function from u1 to y. I think there is no issue here. Just try to solve this, you will get the output. S plus 2 divided by s plus 2 into s minus 1 plus s minus 1 by, this 2 will get cancelled. What else? S minus 1 divided by, this will be s square plus 2s minus s, this will be plus s minus 2 into s minus 1 get cancelled, 1 by s square plus s plus minus 2. Are you getting this? Or it is the option? Okay, right. Oh, this is in plus, I'm sorry. It's in plus, right? I cannot eliminate this too. If I do any mistake, please let me know, okay? Right, this would be s minus 1 as it is. It will become s square plus 2s minus 3. S plus 3 into, or we can split this. Should be plus 2 means minus 1. Hmm. Right? S plus 3 into S minus 1. Okay. This is kind of pole zero cancellation. So the question is the location of poles, right? The location of poles, this will get cancelled, pole zero cancellation. Location of poles will be minus 3. Are you getting this? Any doubt in this? You people are with me?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am. Yes, ma'am.
Right, right. Okay. So the next question is you are asked to find the transfer function from u2 to y. Okay. When you are asked to find the u2 to y, this will be from here. The input becomes this and the output becomes this one. So you have to find a way like this to come here. This becomes the feedback. So now this will go since we haven't considered y2 when considering y1 to y, we are not going to consider y1 when considering y2. So now y1 will I forgot to make this point. So y1 is equal to 0, here y2 goes to 0. Okay, consider y1 is equal to 0. Now the transfer function will be g of s will be the 1 minus s minus 1 by s minus 1. H of s will be the numerator term. I think this is the numerator, s plus 2. Okay, that's it. Just redefine the transfer function. The transfer function when you y2 to y, this will become 1 by s minus 1 divided by 1 plus 1 by s minus 1 into s minus 1 by s plus 2. That's it. This will get cancelled. 1 by s minus 1 divided by 1 plus 1 by s plus 2 will become 1 by s minus 1 s plus 2 plus 1 divided by s plus 2. This becomes 1 by s minus 1 by s plus 3 by s plus 2. So the into s plus 3 into s plus 2. Is it right? If I take inverse, this will go up, this will come down. The answer would be location of 0 for this transfer function is not asked. Yeah, that is right. S plus 2 by s minus 1 into s plus 3. This will become your transfer function. Location of 0 would be minus 2. Zero is the numerator, it will be minus 2. This is the answer. Seventh question. For eighth question, which of the following statements are true? Both transfer function y of s by y1 u1 of s and y of s by u2 of s are stable. Okay. This is first. Second is both unstable. Third is y of s. Okay. TF1 I'm going to take. This is stable. TF2 is unstable. Fourth is the inverse. TF1 is unstable. TF2 is stable. Just to find the stability of the system, what we do? Location of poles we will look, right? If the location of poles in right half of the S plane, this will be unstable. If it is left half of the S plane, this will be stable. This is how we define the stability. For the transfer function, this is transfer function 2. This is transfer function 1. Where it is? Here is a transfer function 1. So if I see this transfer function 1, the pole is in the left half of the S plane, minus 3. So this is stable. So you know transfer function 1 is stable. If I see the second transfer function, this one, I would clearly see one of the poles that is in the right half of the S plane, that is 1. Positive 1 is there. So this will become unstable. So the option would be TF1 stable, TF2 unstable. Any doubt in this? Why did you feel difficult to solve this problem? In what ways you made mistake? Can you recollect?
So basically, what I done, I got my answer like -1, 0, and something like. So
Okay. You didn't consider y1, y2 equal to 0 when considering the.
yeah, actually that there are two inputs. Means like if you can slide up, then I can compare it.
Okay, okay,
Just can you slide up? Then I can tell you what I done mistake.
okay. Where to fast transfer function?
From starting, like from like u1 to y. When we go from u1 to y, answer is s-1 upon s+3.
Oh,
The transfer function.
yeah.
And for u2 to y, the the transfer function is s+2 upon s-1 whole s+3.
Oh, okay.
So basically, there are two inputs, so that made a little
Right. Okay.
from where to start, something like that.
Okay. Now you understood when involving this two kind of two inputs, when considering one transfer function, you should nullify the other.
But yeah, we won't consider the like
Yeah.
if we are going for u1, then we won't consider u2, and
Yes.
when we are going for u2, then
When
we
this will be
not.
easy for you when finding u1 to y, but when considering u2 to y, since the diagram is in this term, suddenly you might not consider this as a g of s and this as h of s. Just try to rewrite this problem. Write like this: u2 goes to 1 by s minus 1 and comes back to s minus 1 by s plus 2. Then you will get this idea, because this will be a negative feedback. If you see, this is a negative here, right? So this is a feedback coming out of it and going to the system. Y2 is positive, so this will become h of s and this will become g of s. Any other doubt in the week 3 graded assignments or practice assignment?
So like and what about stability? How you gave the statement for stability? Means y s upon u1 is stable and y s upon u2 is unstable.
Okay, right. When you see, when we are dealing with Laplace transform, we will be using S, right? This S means sigma plus j omega, where sigma refers to the real and omega refers to the imaginary axis, right? So if I plot a graph like this will be sigma, this will be j omega. So according to the control system point of view, this graph has been divided into positive side and negative side. Whatever the poles, the denominators of your transfer function. Your transfer function consists of whatever there in numerator, we call it as 0. Denominator, we call it as poles. This poles corresponding to the characteristic equation of your transfer function, or you can say this is the roots of your transfer function. Mathematically we call it as roots. In control system point of view, call it as poles. So when the roots or these poles that are there in the right half of the S plane, that is in the positive side, we call this system as unstable.
Okay.
I will mathematically prove why it is unstable. If this is in the left half of the S plane, that is in negative side, if your poles are the roots that is in negative side, we call this region as a stable region. Because when you encounter a system, for example, if I write a transfer function, simple transfer function I would take s plus 2 and 1 by s minus 2. Okay, I am considering, if you take roots of this will give you minus 2, this will give you plus 2, right? So I claimed that whatever it's in minus 2, that is left half of this explain, this is stable, left half stable, this is unstable, I said, right half. Okay, why it is? So when you find this, if this is your transfer function, let's take these are case 1 and case 2. If you find the inverse Laplace transform for case 1, what it would be? E power minus 2t, right?
E to the
1
power
by
e to the
ah
power 2t. No?
minus 2t, no? If
अच्छा
1
case
by
1.
s
Okay,
plus
okay, case 1. हाँ, yeah.
uh,
e to the power minus 2t for case 1. Yeah.
for case 2, this will become
e
e
to the
power
power 2t.
2t.
Yeah.
So this will be your output response, right? So whether this is it's a negative exponential. How this will look like? It will look something like this.
हाँ, yeah.
E power minus at graph. This graph would look something like this.
Yeah.
So this we call it as stable response since it settles down to a value. You don't have to look for its final value forever. Here you don't know where it settles. So this calls as unstable behavior of a system. That's why we are calling whenever the pole. So this pole that is in that root it has in negative would give you some behavior like this. That's why we are calling this system that has roots that is in left half of the S plane indirectly negative roots will give stable response. That's why that is stable system. That which gives unstable behavior is unstable system. Simple. That's it. Good.
Okay, okay, okay. Yeah, unstable, stable. I know about. If at infinite, if we converges to zero, that means it's stable, and
Stable. Yeah.
if it's so obviously it's e to the power 2t. That means when it's coming positive, it
Uh,
becomes
unstable.
unstable,
Right.
and when it comes to the negative, it becomes stable.
Stable. It is because its poles is in the right half of the S plane. Mathematically, its location, it's what matters.
And what about j omega? J omega also plays some role. Means if j omega is
That
positive.
it comes when you have complex poles. For example, that also give the same behavior. If your complex poles always occurs in pairs, it won't occur in as a single, right? So
Yeah.
if this is in, this will be stable. If the poles are in this say unstable. What if some poles might be here, some poles pair might be here? How do you call this? How do you decide whether it is stable or unstable? We have a special name for this that is marginally stable. Marginally stable means you cannot predict this. At this point of view, it is marginally stable. That is what we call it as. It might be stable at some point, it might not be stable at some point. If I push or if I increase the time constant, it might go into the unstable region after some time. We cannot say whether it is stable or not. So we just come up with a generalized term which is in the imaginary what do you call space, this line over this line. Whatever is there over this line, we call it as simply marginally stable. That's it. It might be pole pair or it might be the single pole. Both are marginally stable. Whatever comes falls within this region, it's unstable. This region is stable.
Like in question number 9, we can see that two systems are given.
Question number 9, V3 only, no?
Yeah. So yes, it's correct. So just to discuss, like S1 is given plus minus j omega and plus minus 2 j omega.
Ah,
This is system 2 is given your plus 2 j omega plus 2 j omega.
ah,
So therefore, one is coming with pairs. We can say that it's marginally stable. We cannot conclude that it's totally stable,
yeah.
but we can say it's marginally stable because it's coming at the margin of that y-axis.
Yes, exactly. Right.
And for S2, since both the poles are at the single, means we do not have any pair. We can say that it's unstable.
Unstable. Yeah. Right. If that would be minus 2 j omega and minus 3 j omega, then it is completely stable, right?
Then it's stable again. Yeah,
Right.
marginally
Since
stable.
since this has, it's exactly on the imaginary line. That's why it is marginally stable. You cannot comment on this.
So minus 2 j omega, minus 3 j omega also we cannot say, but we can say it's marginally stable.
Yes, this is stable because it comes inside this LHS, right? 2 minus 2 and minus 3 would come completely inside this after this line. So we can claim this is straight away stable. No problem with that. Because it has this plus or minus. That's why you are telling unstable. Even one pole, it is in the right of the S plane, the system is
Then
unstable only.
it becomes unstable.
Whatever the number of poles is in the LHS, it doesn't matter. Priority should be given to the positive only. If there is only, if either there is only one pole in RHS, or out of four poles, one is in RHS, it is unstable only. That single pole out of four can make the system go to exponential behavior. So this
So
is
we are
unstable.
we are comparing for x-axis now. Means if
Ah,
it's coming above x-axis, then unstable. Then if below x-axis, then
stable.
for imaginary.
Yeah, right. Negative, whatever it has negative value, you can, it might be 0.001 negative, then it is stable only.
And if like positive zeros, 0 point even triple zero one
Unstable.
something like that,
Unstable.
then unstable.
Okay, if you have any other doubts, you can discuss, otherwise we can wrap up.
Ma'am,
Yeah.
actually the doubt, I mean the question which we discussed,
Uh-huh.
and the question 6, actually I'm facing a problem in that type of question.
This question.
Yeah, in this type of question.
Okay,
Yeah,
what problem you are facing?
I don't know how to, I mean, how to start with the problem.
Okay, okay, right. Okay, I will help you. Let me know whether it is helpful. Okay. There is one transfer function. Let's take transfer function 1 and transfer function 2. I call this. Okay, this is the question you have been asked. Forget about the numericals for now. The first question is you want to, okay, this is y, for example. Okay, the first question is u1 to y position is constant here. The second question is u2 to y, that's it. So this is actually a two input one output system. So we are going to simplify this into two one input, oh sorry, wait, 2 into 1 input 1 output system. So we call this 1 input 1 output as single input single output SISO system. Otherwise more than one we call it as multi input multi output MIMO system. So here this is multiple input single output MISO system. That is what we have here, right? So 2 input 1 output, that is MISO system we have, but we are trying to decompose this into 2 into SISO. Is it clear right now? Till now, is it clear?
Yes, ma'am.
Right. Okay. If I want to decompose this multi input single output to two single input, I am going to consider, blindly consider, when I want to consider one way, I am going to consider the next input as 0. That's it. When I consider this way, I am going to consider the other way as 0. Okay, the first scenario, I am taking y1 to y, u1 to y. While considering this, to decompose it into two different systems, I am considering u2 equal to 0. Okay, when I consider this will become u1 plus minus transfer function 2 transfer function 1 into y. Okay, simple. This will always be simple. The problem will comes in the second scenario, y2 to y. When this will become, when I'm considering y1 equal to 0 for this two, I'm decomposing into two different systems. Then this will become tf1 y u2 tf2. Now can you see the difference? So input starts here, this is plus, but the minus is here. Here, when you see here, the minus is here. Wherever the minus is, there comes the feedback. So here, this comes the feedback. So the
Ma'am,
one
the T
next,
of 1 is the feedback.
yeah, the one that is coming right next to the negative is the feedback. So here, this will become the forward gain part. This will become the feedback part. Can you visualize this right now?
Yes, ma'am.
Previously, this becomes the forward gain path. This becomes the feedback path because the one next to the negative sign becomes the feedback, right? Negative feedback we are talking about right now. So this becomes the feedback. That's it. Just rewrite the transfer function according to that. Based on this, for negative feedback, how will you write g of s divided by 1 plus g of s into h of s? Just rewrite this g of s into h of s. That's it. You will have the right answer.
Okay, ma'am.
You got confidence in this question?
Yes, ma'am.
Okay, right. Someone else has any other question, we'll discuss. Otherwise, we can wrap it up. We will. I will also take the Wednesday class. We can move forward with the week 5 content.
Week 5, ma'am, week 5 is not released yet.
No, it's not release date. When it is
Ma'am,
scheduled?
ma'am, week 4 is going on, and the next Sunday is our week 4 deadline. So we can discuss week 4 as well.
Okay, no problem with that. I will come up with some more problems that you can
Try
understand this
to
better.
like GAPA or we will try. Actually, personally, I say I haven't watched the week 4 lecture. We will see the lecture. If we have doubt, then I can ask.
Okay, right. We can discuss, no problem.
Can we discuss these types of problem in the next class?
Yeah, yeah, we can discuss.
Like
Okay, ma'am.
transfer functions, yeah, it's easy, but something like poles, zero,
Ah,
like we create problem like unstable, stable. So it's easy, I know that, but a little practice we need.
okay, we will discuss some transfer function based problems similar to the last one and some pole zero related problems we can discuss. I will come up with some problems like this, okay?
Like one more thing for poles, it asks like in our question number what we discussed like from GA, and from poles we find out it's stable or unstable. What about zeros?
Zero is also same case. If zero is in the right of a place plane, it is unstable zero. Left of it is stable zero. In the on the imaginary plane, it's marginally stable zero. But zeros doesn't really decide what the system behavior is. Zero is for additional support, let's say. But poles really decide whether it is stable or not. So you will not be asked whether the system's behavior based on zero. Maybe you would be asked whether it is unstable zero or stable zero. That's it. It doesn't really mimic the behavior of the system. If you even if you have unstable zero, you can get some stable behavior in the system if your pole is stable.
Pole is stable.
Yeah, I have put
Mainly
mild
it's
here.
like our pole should be in it should be negative side.
Yeah, for a stable behavior, your pole is the first deciding authority, whether it is in the left or right. If it is right, straight away reject, it's unstable. If it is in the left, it is stable. The overall system behavior, I'm telling. We can discuss on pole zero cancellation. What if poles and zeros are in the same place? And next week, I will come up with some problem like that.
Yeah, that would be okay.
Right. Okay. Then see you next Wednesday, coming Wednesday. Okay, we'll wrap up.
Thank you, ma'am.
Thank you. Bye.
Ma'am, and just please share this video. Okay?